In this session, we are going to discuss about the profitability analysis and some other topics like break-even points, then size-capacity relationship and cost index. So, major will be the profitability analysis. Now, you see the profitability analysis is a common practice what we have to do before actually finalizing about a project in relation to chemical plant or any other industry, or even purchasing two equivalent equipments and compare their economic feasibilities. So, there are different ways of profitability analysis. First, before going into that discussion, we have to understand the cumulative cash position, the chart, the timeline, the cash position versus time plot of any project. See, the y-axis we plot the cash position, and in x-axis we plot time. And this is, say, the service life N, and here the startup of production, not the project. Now, we definitely have to design, erect and commission, and finally we should go for this startup. So, first we have to procure from here, maybe some years back, 1 or 2 years back, we are starting a project, right. First, we have to acquire land. So, my cumulative cash position from the line 0, 0, it drops. So, this is for land. Next, we start investing on this design farm, then finalize the design, then go for this fabrication, commissioning, etc. So, that is a part of the fixed capital. So, this is the fixed capital investment. Right. Next, we have to go for paying the deposits and initial this mortgage and initial this security deposits and everything for electricity, for any other utilities, everything. So, this is basically called the working capital. So, this is working capital investment. So, my cash position goes down by a large amount when we are starting the production. Now, once the production starts, definitely we are earning profit, right. So, as we earn profit after some time, including this depreciation and all, after some time this line crosses again the 0 line, and we are going to the profit side. And at the end of the project, we may be somewhere here. So, it is like this, and at that point my cash position will further increase, because we are getting back the salvage, working capital, and we also get back the land. Right. So, average annual profit may be somewhere here, average profit in annual basis and here in a average initial investment. Means the investment, line not going to this side, it is starting from the service it's restricted for the service life. So, whatever total investment we made, if we divide it by the service life, I will get the average initial investment. And the average profit, whatever we incur or whatever we are actually getting from the project, we should mark it here, dividing it by the total service life. So, this is the cumulative cash position, and understanding this, we can now go for profitability analysis. So, profitability analysis. The first one is very simple, the rate of return on investment. So, rate of return on investment is the average annual profit, generally expressed in percentage, divided by total initial investment multiplied by 100 in percentage. Right. So, this is the simplest way of calculating the profitability, that is the average annual profit divided by total initial investment. The profit here may be defined before tax and after tax. So, you see this again describing it again, this profit, how to calculate the profit. The profit before tax revenue from sale minus all expenses except depreciation. Right. So, the tax will be the tax rate multiplied by profit before tax minus depreciation. So, profit after tax is profit before tax minus tax paid, and cash flow, this we have actually stated same, but profit after tax is profit before tax minus the tax paid, and you see this cash flow to the company is profit after tax plus depreciation. So, this is the way of calculating the profit. Now, here the average annual profit may be the profit before tax, or maybe the profit after tax, or maybe the cash flow. Generally, we don't consider the cash flow. It may be either the profit before tax or the profit after tax. And the total initial investment, it may be the fixed capital investment plus working capital investment, or alternatively only the fixed capital investment, because working capital we are getting back. So that's the idea of rate of return on investment. So next profitability analysis is discounted cash flow. So in discounted cash flow, basically we compare the net income generated from the profit as a hypothetical bank whose interest rate, if I keep the investment, my investment over there, and that will accumulate to that final capital. Okay. So rate of return on investment. Sorry, this is not the rate of return on investment. We have discussed it. It is discounted cash flow. Discounted cash flow. So this method consider the time value of money is considered. There is in terms of interest. Right. So here so this discounted cash flow is what? By definition, maximum interest rate. Let me write first the precise definition. The maximum interest rate at which money could be borrowed to finance to finance the project under conditions where the net cash flow, that cash flow to the company, the net cash flow to the project over its life would be just equal or just sufficient to pay all principal and interest accumulated on the outstanding principal. Right, this is the precise definition. Now, definition wise, it's fine. Now, how do you calculate? Say this is your timeline, 0 and n, the service lifetime, the life of the plant. Now, here you have invested fixed capital, you have invested working capital, right. Now, fixed and working capital both will accumulate the interest. So, here you should get back what? Fixed plus working capital into 1 plus I to the power n minus the working capital minus the salvage, because that is basically your time value or time accumulated value of this principal and interest. Pay all the principal and interest accumulated over the outstanding principal. So, outstanding principal is F plus W, and the accumulated amount will be this F plus W into 1 plus I to the power n, but you are getting the working capital back and also you are getting the salvage. Now, you see in the beginning, at the end of year 1, there will be cash flow to the company, predicted after tax cash flow, say it is R1. So, what is that? Predicted after tax cash flow. Which is the profit after tax plus depreciation. Right, predicted after tax cash flow. So, in the same way, at the end of the year 2, we get, or we are getting here, so arrow should be reverse, R2, and in this way Rn. Right. So, this investment and whatever you are getting back and the average profit must be same, must balance each other, and therefrom we should calculate I. So, F plus W into 1 plus I to the power n minus W minus Vs should be just equal to R1 into 1 plus I to the power n minus 1 plus R2 1 plus I to the power n minus 2 plus Rn. Now, if I divide by this present worth factor, F plus W minus W plus Vs divided by 1 plus I to the power n is equal to R1 divided by 1 plus I plus R2 divided by 1 plus I square plus Rn divided by 1 plus I to the power n. So, from this equation or the previous, solve for I, and that is the discounted cash flow measure we have to calculate, and if the I is high, definitely your project is more profitable. So, let us solve an example, and with that we can actually understand what is the discounted cash flow. And this is to be done by trial. We can, this I is to be calculated because it is a nonlinear equation, and we have to calculate this I by trial. So, here, okay, just a minute. Here the cash flow is simply equal to after tax profit. What I have written plus depreciation. Depreciation is not to be included in discounted cash flow measure. Right. Now what is given? Company, year, predicted after tax cash flow. Predicted after tax cash flow, which is income, that is the profit after tax minus all cost except depreciation. Right. Now, what is given? The fixed capital investment is 1 lakh. The working capital investment is 10,000, any unit. Service life is 5 years. And the salvage value is 10,000. And so our total initial investment is 1,10,000. Oh, here it is year 0, so it is 1,10,000. So the year 1, year 2, year 3, year 4 and year 5. So the predicted after tax cash flow is 30,000, here 31,000, here 36,000, 40,000 and 43,000. So these are the given figures. So what we have to use? We have to use this 1,10,000 into 1 plus I to the power 5 minus 20,000, because working capital and this salvage is total accounting to 20,000. So this must be equal to 30,000 into 1 plus I to the power 4 plus 31,000 into 1 plus I to the power 3 plus 36,000 into 1 plus I square plus 40,000 into 1 plus I plus 43,000. Right? And we have to calculate the I. So we can do it in the form of a table. The trial is actually to be listed. Definitely for gate calculation you will not do that. You try to solve and match with the answer. So here, year, cash flow. So next it is the trial with I equal to 0.15. Then we have the discount factor, that is 1 plus I to the power A, and the present value. Right. So year 0, this is 1,1,0,0,0,0. This is the investment. Year 1, 30,000, let us write. Year 2, 31,000. Year 3, 36,000. Year 4, 40,000. And year 5, that is 43,000. And also you are getting back this working capital, which is 20,000, and the salvage. So here, if I go by 1 plus I equal to 0.15, the discount factor comes to 0.8696. Here it is 0.7561. Here it is 0.6576 or 75 point. Here it is 0.5178. Here it is 0.4971. Sorry. This first year we should not write it in this year 0, it is 0.8696, then 0.7561, 0.6576, 0.5718, and this 0.4971. The respective amount is 26,100, that is the present worth of the first year's profit. Next it is 23,400. Next it is 23,300. Next it is 22,900 and 31,300 of this total. Right. So, actually you see what we are doing, you are basically 1,10,000, we keep it as it is, here 30,000 divided by 1 plus I plus 31,000 divided by 1 plus I square plus 36,000 divided by 1 plus I cube plus 40,000 divided by 1 plus I to the power 5 plus 43,000 and this 20,000 divided by 1 plus I to the power 5, and that comes to be 31,000, right, nearly half. This is 63 and 0.49, so that is 31. So, this is the calculation we are making. So, what is the present worth? Here it is 1,27,000. So, it is not matching. So, we will go for another trial with I is equal to 0.2, and in this way we will continue, and finally, if we do it for I is equal to 0.207, the present worth is exactly 1,10,000. So, my answer of this discounted cash flow will be I is equal to 0.207. So, that is the calculation associated to this discounted cash flow. We try to understand that we have to consider the profit after tax, but we should not add depreciation here, right, that is the methodology. So, next is the net present worth. So, net present worth we can understand from here. So, net present value or net present worth. See the timeline again, if we incur that at the year 0 we have given a total investment, right. So, F plus W. Now, in the first year if you have a profit R1, or rather we should call it cash flow to the company without considering the depreciation. So, this reduces to R1 prime. Second year you have a profit R2, this reduces to R2 prime, and in this we get the profit Rn plus the working capital plus the salvage value. So, you project it here, this will be Rn prime plus Vs prime plus W prime, right. So, net present worth we will calculate as this Rn plus W plus Vs divided by this is the year n, 1 plus I to the power n plus Rn minus 1 divided by 1 plus I to the power n minus 1, and in this way R1 divided by 1 plus I. So, that is the positive side, and you have invested F plus W. So that will give you your net present value or net present worth, right? Just like the net present worth for an interest rate, the bank interest rate I equal to 0.25 will be 1,27,000 minus 1,10,000. It is coming to be 17,000. So net present, this is the present value. So net present value is this minus the initial investment. Net present worth is 1,27,000 minus 1,10,000. So it is coming to be 17,000. So that will be your net present worth. So you have to understand the basis. In the previous calculation or previous mode of profitability calculation, we have considered I, but here we have a fixed I, which is the bank interest rate. And with that bank interest rate, we have to calculate the net present worth, right? So higher be the net present worth, more profitable be the project, as it is obvious. So next, we will consider again the capitalized cost. So low be the capitalized cost, which is the procurement cost plus perpetuity. Again, we will discuss about it, though we have calculated the capitalized cost, but here we will do it once again, because here the idea is profitability analysis, right? So my third measure of profitability, it is based on cost, is capitalized cost. It is not looking into profit, right? And it is typically a cost analysis, more pertinent to think about or select the optimum, so select the best one from a group, best one of the options, device and all from a group. Right. So you see, it is based on perpetuity. We have initially invested the procurement cost, that is CV, and invested the perpetuity. So capitalized cost is CV plus perpetuity. Now what is perpetuity? After the service life, it will generate an amount from which will be P into 1 plus I to the power n, and you are taking away the replacement, so you will again generate the perpetuity. So obviously P into 1 plus I to the power n minus CR is equal to P. So P is equal to CR divided by 1 plus I to the power n minus 1. So capitalized cost is CV plus CR divided by 1 plus I to the power n minus 1, right? And as we have mentioned that CV is replacement plus salvage plus CR divided by 1 plus I to the power n minus 1. So we get VS into CR into 1 plus I to the power n divided by 1 plus I to the power n minus 1. So that is the capitalized cost. Either you use this expression or we use this expression, whatever is available. So we don't consider here the inflation or deflation, that is the CR and CV. CV is same, CR remains unchanged, right? CV is the origin, and CV change actually will affect indirectly the CR change, but basically we should focus on CR because finally it is salvage and the replacement. So if the capitalized cost is low, definitely that specific option we should go for. Next, it is the payback period, payback period. It is basically, let's state the formal definition of this payback period or payout period. Payout period or payout time. Let's write payout. Defined as a minimum length of time theoretically necessary to recover the original capital investment in the form of cash flow to the project based on the total income minus all cost except depreciation. So, formally it is defined as the minimum length of time theoretically necessary to recover the original capital investment in the form of cash flow to the project based on total income minus all cost except depreciation. Right. So, we may consider the time value of money or we may not. That depends on us. So, what we were? So, without interest, without considering interest. This is the payout period. This is the fixed capital, depreciable fixed capital investment. And depreciable fixed capital investment is basically F minus Vs. Remember this, it is not only F. Next is average annual profit plus this average depreciation. Here in this profit calculation, we must consider profit after tax. So, this is basically the cash flow, right. Theoretically, that we define as cash flow with interest consideration. The payout period is depreciable fixed capital plus working capital investment. Depreciable fixed capital investment, that is F minus Vs, plus interest, because working capital you are getting back. So, basically what you are investing is this interest of the working capital and the fixed capital as well. Interest of working and fixed capital, that is F plus W into 1 plus I to the power n minus 1, that is the interest, right. Denominator will be average annual profit plus average annual depreciation, the same as previous, as constant annuity basis. What does it mean as constant annuity? See, your profit after tax, let us say it is R1, R2, R3 and in this way Rn. Right. So, the total profit after tax, S profit, is R1 into 1 plus I to the power n minus 1 as Rn. Right. So, this we simply divide as constant annuity, just like if I pay equally. So, this SP should be R into 1 plus I to the power n minus 1 divided by I, and from there we calculate R. Right, the average annual profit. And similarly, average annual depreciation as constant annuity basis. So, we have to go for this individual depreciation per year, right, and basically we have to use the sinking fund method to calculate this average annual depreciation, right. So, this R should be the average annual depreciation, which is accumulating to V minus Vs. So, R will be the amount. This in sinking fund method we have calculated something R. So, that R will be the amount of average depreciation per year. So, with this understanding, this is all about this profitability analysis. With this understanding, let us solve an example problem. What is given? So, here the profit is given after tax profit. See 1, 2, 3, 4 and 5. Right. Then the after tax profit is given as 30,000. Then this 31,000. Then here 36,000. Fourth year it is 40,000 and fifth year it is 43,000. And here it is stated that we do not have to consider the interest. So, as we do not have to consider the interest, we will simply calculate the annual profit. Right. The annual profit is basically the profit after tax minus depreciation. It should not be plus, it is minus depreciation. So, depreciation here, as we again are not considering this interest, so we can go by straight line method where it is equal. Right. So, the capital investment, fixed capital investment is 1 lakh, working capital investment is 10,000, salvage value is 10,000. Right. So, the depreciation delta V is 90,000. So, 90,000 divided by the rate of depreciation is 90,000 divided by 5. So, it is coming to be this 18,000. So, from the profit 30,000 we have to subtract 18,000. So, we will get 12,000. Right. Similarly, here it is 13,000. Here it will be 18,000. Here it will be 22,000. And here it is 25,000. So, if I sum it up, it is coming to be 90,000. So, the average profit is 18,000 per year. Right. Now, your fixed capital, depreciable fixed capital. So, payout period, how will you calculate? Depreciable fixed capital, it is 1 lakh minus 10,000 divided by average annual profit, which is 18,000, plus average annual depreciation, which is also 18,000. Right. So, together it will be the cash flow. And here it is the annual profit, net profit. So, cash flow and net profit are different. Right. So, profit after tax plus depreciation is cash flow, and profit after tax minus depreciation is the net profit or annual profit. So, we get an answer of 2.5 year. So, if I have to calculate consider the interest or time value of money, how will you do that? So, this profit here, this annual profit minus depreciation, you have calculated. This depreciation should be considered as this straight line method. It will be told that what method you have to consider. So, accordingly you will calculate the profit, right, and then you convert into this uniform annuity. So, that will be your average annual profit. And average annual depreciation, that is again the depreciation per year cumulated to a sum, right. So, just like here, see, this is R1, this is R2, this is R3, this is R4, this is R5. So, first for the profit calculation, this is R1, R2, R3, R4 and R5. What will be your average annual profit? So, you consider it as R into 1 plus I to the power n minus 1 divided by I. So, this will be equal to R1 into 1 plus I to the power 4 plus R5 in this way. So, you calculate R. So, R will be your average annual profit, right. R will be your average annual profit. And if you know the depreciation per year, this is DA1, DA2, finally DAN, right, in the last year. So, at the end of each year basis it is 0. So, average depreciation you can also calculate as DA into 1 plus I to the power n minus 1 divided by I as DA1 into 1 plus I to the power n minus 1, DA2 1 plus I to the power n minus 2 plus DAN. So, this DA will be your average annual depreciation, right. So, average annual depreciation you calculate, average annual profit you calculate. So, you then substitute it here and calculate the depreciable fixed capital, which is here for 90,000, and this working interest on this working and the fixed capital, and from there you calculate the payback period. So, definitely here the depreciation here it's being calculated by straight line. So, every year its value remains same. So, that is 18,000. So, what will be my calculation? Here 90,000, that is a depreciable fixed capital investment, plus 1,10,000 into 1 plus I, whatever is the interest rate, 5 minus 1. So, that divided by this profit is R plus 18,000. Right. So, that will be my payback period. So, with interest and without interest, we can calculate the payback period. Next, so that's all about the profitability analysis. So, note the method: rate of return on investment, discounted cash flow, net present worth, capitalized cost, and payback period. So, next we will try to understand the break-even point, which is the not the optimum, but condition or rate of production which will give us no profit, no loss situation. So, it is break-even point. Rate of production is n units per day, right, or per year or whatever, per time. Let us write not per day, per time, whatever is the time frame. Selling price, so it is C per unit. Operating cost, there is F, a function of N, and fixed cost, it is another say C1. So, what will be my break even? C into N minus C into N, that is the sales revenue, minus C1 minus Fn, and that we should, this is equal to profit, right, and that we should set equal to 0, we get break even point, and that we maximize upon going by dPdN equal to 0. So, it will be C minus derivative of N. So, that is the optimum production. So, that is all about the break even, and we can have a graph. See, this is the curve of C into N. This is C1 and this is function of N, right. So, C1 plus function of N is this, C1 plus function of N. So, where it intersects, it becomes the break even. Right. So, that is all about the break even point. Next, it is about the cost index. So, actually the cost index accounts for inflation or deflation. Say cost of a device A, cost of a device in year A. So, it is basically introducing a concept or measure of utility, right, of that device. So, we will divide it by cost index of year A, right, and that will be supplied to you, right. Cost index is an economic term, and so cost of the device in year, any year, divided by cost index of that year is a measure of utility of the device. So, this must be, the utility remains same, it remains unchanged, right. So, cost of the device in year B divided by cost index of year B. So, in this way we have to use this cost index formula, and we have to update the cost of a device in year B knowing its cost in year A and cost indices of year A and year B. That is the utility basically. Next, cost capacity relationship. So, cost is generally considered to be proportional to the capacity to the power 0.6. That is for the process devices. So, cost of size S1 divided by the cost of size S2 is equal to S1 by S2 to the power 0.6. Right. So, that is all about the project engineering, and in the next session we are going to solve some gate problems using this understanding what we have developed in these two sessions. Thank you.